Welcome dear students. Abki baar 80 baar. Let's do it again with application of derivatives. Application of derivatives is most important chapter of math. Quadratic equation sequence, because a lot of other chapters also take relevance of definite integrals, and also some questions on algebra would need application of derivatives, and also some parts of sorry so application of derivatives relevance is found in quadratics, algebra, definite integrals, remaining part of indifferent integral, differential equations, areas, and also in some areas of coordinate probability and relevance of application. Combination questions can always be. That is how pure application of derivatives comes. Along with it, there may also be questions from other chapters like algebra or somewhere else. Here you can find relevance of application of derivatives. So without any further ado, let's jump on to first part of application of derivatives. If you start to classify into further subtopics, first part would be tangents and normals. Tangents and normals is a topic to learn. Problem type and definitely questions are being asked on it. And second topic would be monicity, maxima, minima, value theory. These are the sub areas. Tangents and normals. Most of you already know right from your physics classes that dy by dx represents slope of tangent to the curve at any point. Geometrical meaning it is slope of tangent. Let's say this is your curve y is equal to f of x, and I have drawn a tangent at the point P. I am drawing a tangent at the point P. Phi is the tangent. So tan phi here dy by slope of the tangent of this line. Of course, if tangent slope is dy by dx, normal slope minus d, normal slope dx minus dx by dy. So start. You can find in application of derivatives slope of tangent and normal at any curve. Let's look at question on this. At the point 1 comma 0, for the curve y is equal to minus 1 by x. He is asking you to find slope of the tangent. By dx, what you need to find. So you can apply u by v rule here. Rather, what I would like to make. So this is 1 plus 1 by x minus by dx. Here. And at which point are we finding 1? Just put x is equal, have the slope ready. Minus 1 and inclination is 135 degrees. So it's a simple warm-up question. Right away we jump. Equation of the tangent. Equation of tangent point. What we are doing, you know the slope, it's given by dy by dx, right? Dy by dx. And once you know the slope m, you already have the point at which you are drawing 1 comma y1. You are drawing the tangent at the point x1 comma y1. So your tangent slope is known. It is also known that it is the point x1 comma y1. Y1 is equal. Number here is simple. along with the slope difference. And equation of normal, again, normal also passes through. The point is already known. Slope, just now we discussed, it is by minus. Equation of the normal would be y minus y1 is equal to minus by at x1 comma y into x minus x1. That will be normal. Sometimes what happens is the equation may also be given parametric x in y in term. So in that case, dy by dx, how do you find? Dy by dx will be y by dt by dx by dt. As simple as that, rest everything remains. So equation of the curve will be given by y is given the function dy by dx. How to find? Dy by dt by dx dash t by f dash. That will give you x minus the entire normal equation. Very simple thing. Let's state parametric. X is given as a function of theta and y is given. So let me find it minus d normal. Minus d by d theta divided by d. Now when you differentiate y with respect to theta, what will you get? A remains as A remains the numerator. Derivative of sin theta minus theta cos theta minus theta cos theta into, so again you can see cos theta theta sin. Let us look at derivative of numerator. I have to put, and then x by d theta what cos theta plus again you can, so theta theta also get cancelled. You know slope of the normal, you know the point, so equation of the normal will be cot theta x1. As simple as that, depending on the options. Next part, interesting thing, will give a given a implicit equation. This is not in the form y is equal to written in. It is a combination of both x. So in such cases, how do you find of tangent? So here, without any simplification, we will directly go for differentiation with respect to x. So I will differentiate the equation with respect to x. When I am differentiating this with respect to derivative of y will be, what I want is slope of the normal is by dx. Now in order to differentiate x over y, x is also a function, y is also a function. So it is function, all this function. Now what will be log t? To differentiate on both sides. Log t derivative is 1 by t, 1 by t derivative of y log x. What is derivative of y log x? Derivative of y plus y into derivative of log x. So I'll take this dt by dx and read y dash x plus y by. Okay. Now where are you supposed to find the normal? The point where it cuts x axis. That means y coordinate at this point is 0. Y coordinate is 0. Coordinate power is 0. Power 0. So we are finding equation of the normal at the point. First finding the 1 comma. At 1 comma 0, I am writing the normal equation. 1 comma 0 normal equation, what will it be? At 1 comma 0, normal equation would be y minus 0 is equal to minus dx by dy, that is minus 1 by y dash, minus 1 by y dash, minus 1 by y dash, let me find the value. So push all the numbers 1 here. What will you get? 1 plus y dash at the point 1, y is log 1 is 0, y is already 0, so this whole thing is 0. So y dash is how much? Minus 1, right? Y dash is minus 1. So slope, how much will it be? Minus 1, 1 plus of the normal here. Want to equate the normal. Y minus, that will be normal. Okay, so will we move on to the next question? Before moving on to the next question, there will be a lot of differential equations, questions and equations which construct a differential equation using, can also be in other chapters, but times intercept of tangent on y axis, intercept on tangent on y axis point. What will be your tangent dash into tangent equation? So we want intercept of tangent on x axis. So for finding the tangent intercept on x axis, we have to put y is equal. Once you put y is equal to 0, minus y divided by y dash is equal to x. So x intercept, what is it? x1 minus y1 into 1 by dy y dash is nothing but dx by, so x intercept will be how much? Modulus of, if you the absolute value, then modulus of x1 minus y1 into, if you don't remember it, not necessary that you remember it, no tangent equation. For x intercept, put y is equal to 0, for y intercept, put x is, and calculate the coordinate of y intercept. You have to calculate the y coordinate by putting it. You are finding the x intercept, you have to put y is equal to 0 according. So intercept on y axis, instead of putting equal to 0, now I will put y is equal. Once I put y is equal to 0, y1 minus x y dash, y1 minus x y dash. So once you write the equation, be simple. Similarly, for equation of tangent at any point to be parallel to x-axis. Parallel to x-axis, what should happen? Dy by dx should be 0. And for perpendicular to the x-axis, dx by dy should be 0. Similar thing, you can also find it for normal, whether it is parallel to x-axis or perpendicular to x-axis. There will be question asked on. Then there will be another term which is regularly used. The tangent or normal is equally inclined to both the axes. If any line it is equally inclined to both the axes, what does that mean? Slope of that line will be either plus 1. Okay. So if tangent or normal equally inclined to both the axes, this is the phrase which is also used in coordinate geometry. The line is equally inclined to both the coordinate axes. What does that mean? Slope of that line is either plus 1 or minus 1. Okay. So, and next regular thing which is asked in coordinate geometry as well as in application of derivatives as in is a line makes equal intercepts on coordinate axis. Line makes equal intercepts on coordinate axis. So when a line makes x-axis, x-intercept and y-intercept are both happen only when is 135 degrees. That means slope of the line should be, or in the intercept form, by a plus y by b, a and b are both same. So what will be slope of the line? It will be minus 1. So these are some things which you have to very quickly, but let's convert the English given into a mathematical. Next point, tangent to a curve at the point x1 comma y1 can be drawn even though dy by dx does not exist. Even though dy by dx does not exist. Some people have this at any point, then it will not have a tangent. That's not the case. That cases it may have still have a vertical tangent. If you look at the graph of x power 1 by 3. So the graph. Inverse of x cube. We touch x-axis, it's 0. So how will be y is equal to x power 1 by 3? Will touch y-axis at 0 comma 0 comma. That means it has a vertical tangent. Vertical tangent. So y is equal to x power 1 by 3 at 0 comma 0. Though it is not differentiable at 0. So whenever dy by or denominator of that expression, so don't conclude that the tangent may be a tangent. So to carefully check that. So straight away let us jump on to questions. Question reads the locus of all the points. Find the locus of all the points on the curve at which the tangent is parallel to x-axis. Parallel to. So where will the tangent, when will the tangent be parallel to x? Of course, when dy by dx be 0. Now if dy by dx is, what will you get? 2y y dash. 2y y dash is 4a into derivative of x plus sin x by a. 4a is anyways a constant. Cos of x by 1 by a. Cos of x by a cos of x by minus 1. But if you see cos of x by a is equal to minus 1, they're written there. The options are in terms of y. So if cos of x by a is minus, what will be sin of x by a? 0. Cos of x by a is quantity is y square of points. Y square. Locus is not, but which of the following conditions satisfied would be the right question. But where question is being given this way, I am not changing the question, but you have to understand that not the locus of all, the condition which the points on this curve which are parallel to x-axis satisfy. Is that okay? Cos of x by a is minus 1. That implies sin of x by a would be curve would be y square to 4ax. Which of the following points lie on the tangent to the curve? At the point 1 comma. Point 1 comma. So such type of question, you have to find the tangent. Straight away, if you find the tangent, maybe you can indulge in some shortcut. That is the reason he is asking you. Hiding the tangent. Okay. Which of the following points lie tangent? Find the tangent. Comma 0. So how will be the tangent equation? Y minus at the point 1 x minus coordinate of the. Now to find this, you need to find dy by dx point 1 comma. Again, this is a implicit. Okay, for implicit curves, what will you do? Straight away differentiate. So I want to curve x bar 4 bar y plus 2. Differentiate it straight away. We rule derivative of x bar 4 is x cube. So second function as it is plus derivative of first function. What will that be? X bar 4 into derivative of second function is e power y as it is plus what is derivative of e power y derivative is e power y into y dash, power y into y dash. Dy by dx will also be there. Here I am writing in different dx, but here there would be one dy by dx plus what is the derivative of 2 root y plus 1? What is the derivative of 2 root y plus 1? 2 into power is 1 by 2 into 1 by root over y plus 1 into y dash is equal to derivative of 3 is 0. Okay. Now at which point I have to find 1 comma 0. In such questions, parallelly you can put 1 comma 0. Parallelly you can put 1 comma 0. Instead of writing all of this, once you found this term, there itself you can substitute. So x is 1, y is 0, y 0, e power 0 is 1, 1 cube is 1, so this is 4, 1 power 4 is 1, e power 0 is 1, y dash plus 2 gets cancelled, y is 0, so this is also y dash is equal to 0. Implies y dash is equal to minus 2. So tangent slope is how much? Minus 2. So substitute minus 2 here. Y is equal to minus 2 into x minus. Now what all points satisfy? He says option C satisfies. Let us straight away check with this point. Nothing but you have to check, no other go. So this is your tangent equation. You just have to see what all points satisfy. Okay. So minus 2 comma 6. X if you put minus 2, it is minus 3. Minus 3 to minus 2 is 6. So option C is the right option. You can also check with the options straight away from the start or from the end. So wherever it satisfies, that will be your option. Simple. Okay. Next question. There is a tangent which meets x-axis at A and y-axis at B, such that AP is to BP is 1 is to 3. AP is to BP is 1 is to 3. Read the question, understand it carefully. a tangent to the curve y is equal to f of x. There is some curve. At the point P, you are drawing a tangent to cut x-axis at A, y-axis at B. Y-axis at B. AP is to BP, he says, is 1 is to 3. If this is 1, he says this is. Okay. What is this point? X comma y. So can you straight away find the tangent equation? What will be the tangent equation? See, this point would be something comma 0. This point would be 0 comma something. B, because it is on y-axis, it will be 0 comma something. A, because it is on x-axis, it is something comma 0. Now apply section formula. 3 into 0 plus 1 into whatever should be equal to 4y. So this point is how much? 4. To avoid confusion, I will put this x1, y1, this will be y1. Okay. Similarly, 3 times of this point plus 0 by 4 is x1. Okay. So 3 times of this point is 4x1. This will be 4x1 by 3. I am not using anything other than the section formula. You can happily apply your section formula. Call this point 0 comma b, call this point a comma 0, apply section formula, get the values of a and b. You will get 4y1 and 4x1 by 3. Okay. Now what will be equation of the tangent or slope of the tangent here? Slope of the tangent dy by dx will be y1 minus y2 by x1 minus x2. If 4 gets cancelled, it will be 3y1 with a minus sign divided by x1. Okay. So this question got converted into your differential equation. Because I am not writing any line equation, instead of x1 comma y1, I can also call them x and y. I can also call them x and y. Had I had to write line equation, then it would be preferred to write x1 comma y1, but I don't think it is necessary here. We are not writing any line equation. So dy by dx, how much will it be? y2 minus y1 by x2 minus x1. 4 gets cancelled. It will be minus 3y by x. Now it's a variable separable question. Simple. dy by minus 3y is equal to dx by x. Integrate on both sides. Add your integration constant. This will be minus 1 by 3 log y or log y plus 3 log x equal to some constant. Or the curve is yx cube. When you multiply them, y to x cube equal to some constant will be the curve. Okay. Now f of 1 is given to be 1. That means when x is 1, y is also 1. So k will be 1. K will be 1. So yx cube will be equal to 1. This is the curve equation. F of 1 is given to be 1. That is when x coordinate is 1, y coordinate is also 1. So k value should be 1. So what is your curve? Yx cube is equal to 1. So y when it is 2, x cube will be how much? 1 by 2. X cube will be how much? 1 by 2. Or x when it is 2, y will be how much? 1 by 8. So option C is the right option. You can also check with the remaining thing. Okay. Very simple question, but basically this is a differential equation question which is using the concept of application of derivatives. So differential equation is not the major part here. Application of derivatives is, and it is also using some basic ideas of coordinate geometry. So these type of questions will be asked. Angle between the tangents, I'll come back to this. Okay, so straight away he is asking you to find tangent slope at this point 2 comma 0, find dy by dx. dy by dx is 2x minus 5. Find slope of the tangent at 2 comma 0. At 2 comma 0, how much will be the slope? Substitute 2 here, minus 1. At 3 comma 0, how much will be the slope? 1. These two are perpendicular to each other, so angle between them will be 90 degrees. Simple, straightforward question. Next point, once you have understood tangents and normals, then there is something which is very important again in application of derivatives. You need to know what is length of tangent, what is length of normal, what is length of subtangent, and what is length of subnormal. So you need to remember this formula. Length of the tangent is given by y by m root over 1 plus m square. Y coordinate of the point divided by m is dy by dx root over 1 plus m square. Okay, and length of normal is given by y root over 1 plus m square. Y root over 1 plus m square. Y coordinate y1 of the point root over 1 plus m square. In all the cases, m is dy by dx. All of these cases, m is dy by dx. Length of subtangent will be how much? Modulus of y by m. Y coordinate by m. And length of subnormal will be modulus of y into m. Proof of this will be simple. Not very complicated, but you need to understand the geometrical meaning of what is tangent length, what is subtangent length, and what is subnormal length. At any point P, if you are drawing a tangent, to cut x-axis at the point T, that red color line is length of your tangent. PT is called length of the tangent. Similarly, if you are drawing normal at point P, to cut the curve at, to cut x-axis at n, Pn is called length of the normal. Pn length is called length of the normal. Pt length is called length of the tangent. Now draw a projection of P on x-axis. Draw foot of the perpendicular from P on x-axis. Let's say this is your foot of the perpendicular on x-axis. M. Then the length mt, it is called subtangent. The length mt, it is called subtangent. This length is called subtangent. And the length pm is called subnormal. The length mn is called subnormal. This length will be your subnormal. This length will be your subtangent. This length will be your tangent length. This length will be your normal length. So basic geometry or basic trigonometry will give you the results. How much is this angle? Tan inverse of m dy by dx. So tan of phi is dy by dx. This length is y. Opposite side by adjacent side is your subtangent. Adjacent side is your subtangent. Will give you tan phi. From there, happily you can find subtangent. You can find subnormal from this triangle. Hypotenuse length will be your tangent length. Hypotenuse in this triangle will be your normal length. So basic geometry will give you all these results. Don't bother about the derivations. Remember all these four formulae. They will very handy. The question can come directly in application of derivatives or with a combination of differential equations. So question can be, there is a curve whose length of the tangent is 2 times the length of the subtangent. Then you will form a differential equation, and from there you will be able to solve and find the curve. So how will this question be? Let's look at a simple question. A curve is given, x bar m plus n is equal to a bar m minus n into y bar 2n. X bar m plus n is equal to a bar m minus n into y bar 2n. अब इसमें क्या प्रूव करना है? Subtangent to the power m. We have to prove that quantity is proportional to subnormal power m. Now what is subtangent? Subtangent is y by m. Let me not confuse with that m. Subtangent length will be y by y dash or dy by dx. Subnormal length will be y into y dash. Now what I have to prove is y by y dash power m is proportional to y into y dash power m. Now you can see y power m is this is what we need to prove. Proof will be very simple. Find y dash first. How much will be y dash? Differentiate on both sides. Here derivative will be m plus n into x bar m plus n minus 1. This a power m minus n, you can take it to the other side, into what is derivative of y power 2n? 2n y power 2n minus 1 into y dash. Y dash is what I wrote here. So y dash will be m plus n x power m plus n minus 1 divided by a power m minus n 2n y power n minus 1. Is there any simpler way with which I can simplify this? I know x power m plus n is nothing but a power m minus n into y power 2n, or x power m plus n by a power m minus n will be nothing but y power 2n. So I will remove this minus 1 here and write x term in the denominator. I can write x term here. Similarly, I will remove minus 1 here and write that y here. Now x power m plus n gets cancelled with a power m minus n and y power 2n. So what will you be left with? Is m plus n divided by 2n into y by x. This will be your y dash. This will be your y dash. Now what is that we need to prove? Y by y dash. Y by y dash. Y by this quantity. How much will it be? 2nx divided by y gets cancelled. M plus n. 2nx divided by m plus n will be your subtangent. Whole power m. We have to prove that it is proportional to y into y dash. Y into y dash. What will be y into y dash? M plus n by 2n. Y into y is y square by x. Whole power n. Okay. So to prove that two quantities are proportional, their ratio has to be constant. Their ratio has to be constant. If I divide one by the other, here x power m is there. In the denominator x power n is there. So you will have x power m plus n. Y power 2n is there. You know x power m plus n divided by y power 2n is a constant. So this ratio of these two things will automatically be a constant. So you cannot clearly say one is proportional to the other. You can write simply one more step. This divided by this or this divided by this. You can see x power n coming up. X power m plus n and y power 2n, they get cancelled with each other. Once they get cancelled with each other, you can say the ratio is a constant or one is proportional to the other. As simple as that. Then you have a concept called angle of intersection between two curves. Let's say there are two curves, y is equal to f1 of x and f2 of x. To find angle of intersection, what you have to simply do is find the point of intersection. First step is to find the point of intersection. Once you found the point of intersection, at that point, find dy by dx for the first curve and dy by dx for the second curve. Let one of them be called m2, other one be m1. So m1 slope of the tangent at the point of intersection is known to you. M2 slope of the tangent to the second curve at again point of intersection is known to you. Angle theta is given by tan inverse modulus of m1 minus m2 by 1 plus m1 m2. This formula is straight away coming from your straight lines chapter, angle between two lines. So angle between two curves is nothing but angle between the tangents at the point of intersection. First find the point of intersection, find slope of tangent to the first curve, find slope of tangent to the second curve, and once you know both the slopes, m1 minus m2 by 1 plus m1 m2 will give you angle between the curves. Very simple. So two curves are given to you. First thing, what is that we need to do? We need to solve the curves to find the point of intersection. We need to solve the curves to find point of intersection. So 2 sin square x is equal to cos 2x. So he has clubbed trigonometry into this simple trigonometric equations. Now there may be too many points of intersection. These are sinusoidal curves. There may not be a single point of intersection. If there is one, there will be infinitely many because they are periodic functions. So you can find angle between the curves at any one point. So find out any one solution. I need not write the general solution here. Any particular solution will do. How to solve this curve? 2 sin square x is equal to cos 2x is 1 minus 2 sin square x. So effectively sin square x is how much? 1 by 4. Our one point of intersection is x is equal to pi by 6. Sin x is half is one point of intersection. Then sin x is half pi by 6. That is your point of intersection. At point of intersection, he is asking you to find angle of intersection. Okay? He is asking you to find angle of intersection. So find dy by dx for the first curve. Y dash is equal to 4 sin x cos x. At which point are we finding y dash? At x is equal to pi by 6. Substitute x is equal to pi by 6. What will be slope of first curve? Sin pi by 6 is 1 by 2. Cos pi by 6 is root 3 by 2. So root 3 to 1 by 2 into 1 by 2 into 4 is root 3. So this is slope of tangent for the first curve. And what is slope of tangent for the second curve? Y dash is equal to 2. Derivative of cos x is minus sin x. 2. Write it outside. So for this curve, x is pi by 6. Sin 2 into pi by 6 is sin pi by 3. Sin pi by 3 is how much? Root 3 by 2. So this is minus root. Minus root 3. He is asking you to find angle of intersection of both the curves. Angle of intersection of both the curves. Okay. So one tangent is at 60 degrees inclination. Another tangent is at 120 degrees inclination. Then this angle will be 60. So what will be angle between the tangents? Angle between the tangents is also 60 degrees. Or you can find out tan theta is m1 minus m2, minus of minus root 3 is plus 3 by 1 plus m1 m2 plus m1 m2 is minus of 3. So how much is this? 2 root 3 by minus 2 or root 3. Tan theta is root 3. So angle will be pi by 3. This is how you can find angle of intersection between two curves. Next, two curves are given. X cube minus 3y square is equal to a square and 3x square minus 3x square y minus y cube is equal to b square. So most of the times challenge in such questions is in terms of only finding the point of intersection. So in previous case it was a trigonometric equation. Let us see what it is here. X cube minus 3xy square is equal to a square. And what is the other curve? 3x square y minus y cube equal to b square. Now I have to find point of intersection of these two curves. If you look at these terms, four terms together, you can recall the formula of a plus b whole cube. A plus b whole cube, what is it? A cube plus 3ab square, 3 plus 3a square b plus b cube. Yes or no? So I'll subtract these two equations and also add these two equations. If I add these two equations, what will I get? X cube minus 3xy square plus 3x square y minus y cube. This is equal to a square minus b square. Square minus b square. If I subtract them, what am I getting? X cube minus 3x square y minus 3x y square plus y cube is equal to a square minus b, equal to a square minus b square. So from here, let me see if anything can come out common. No, this is not coming in the formula of a cube minus b cube. There should be plus sign here and minus sign here. Okay, so there is some problem with the signs given there. There is some problem with the signs given there. So a cube plus b cube formula is not working out. Let us see if you can get from here or if there is some mistake in the question. So what is that we need to do? This simplification is not pretty evident. In first one, I can get x minus 1 common, x minus y into x cube minus y cube is x minus y into x square plus y square plus xy. Then in the second term, if I take 3xy common, I am getting x minus y. So plus 3xy is equal to a square minus b square. Let me observe similarly for the second one. X plus y I can take common into, what do I have here? X square plus y square minus xy. Then I have minus 3xy. This is a square nope, these two are not getting cancelled. So this won't work for us. Let us straight away see if we can observe the point of intersection or straight away can we do it from differentiation. Let me attempt to find out y dash for the first curve. I'll differentiate it. 3x square minus 3y square UV rule minus 3xy y dash is equal to 0 for the first curve. And for the second curve, minus 3y square x square y dash minus, here also it is 6, also it is 6xy equal to 6. From the first equation, y dash is 3 gets cancelled throughout. X square minus y square divided by xy is y dash value. From the second equation, what is y dash? Y square also 2 plus 2xy divided by x square is y dash. Absolutely not, they are not getting cancelled. So there is some problem with the sign in the question. Ignore it. Probably it should be plus sign and plus sign here. Then you will be basically idea in this question is to add a plus b whole cube, add and get a plus b whole cube formula, subtract and get a minus b whole cube formula, from which you will get x plus y and x minus y values. Some typo is there in the question. Okay. So similarly, find the condition that these two curves are orthogonal. Whenever two curves are orthogonal, what will happen? Angle between them should be 90 degrees. Angle between them should be 90 degrees. So dy by dx for the first curve multiplied by dy by dx for the second curve, it should be equal to minus 1. So this is also a calculation intensive question. Nothing noteworthy here. 2a1x plus 2b1y y dash is equal to 0. So what is slope of tangent for first curve, we are talking about first curve. Y dash will be equal to 2 gets cancelled throughout minus a1x by b1y. Minus a1x divided by b1y will be your y dash for the first curve. That's for second curve. Same thing, a1 is replaced by a2 and a2x by b2y. You know, product of these two slopes is minus 1. So from these two, what you get is product of the slopes a1 a2 x square by b1 b2 y square is equal to minus 1. Equal to minus 1. Okay. So a1 a2 x square plus b1 b2 y square is equal to 0 is the third equation. Now if you see x square y square are satisfying these three equations. X square y square are satisfying. First equation is a1 x square plus b1 y square is equal to 1. Second one is a2 x square plus b2 x square is equal to 1. Third one is a1 a2 x square plus b1 b2 y square is equal to 0. So whatever point of intersection x comma y you are talking about is a solution for all the three curves. So when three linear equations have a common solution, it is possible only when net of all the coefficients is 0. So if you talk about the lines a1x, b1y equal to 1, a2x, b2y equal to 1, a1 a2x, b1 b2y equal to 0. These three equations are satisfying the point x1 x square comma y square. So three lines are concurrent. That is what we mean. Three lines are concurrent, and that will happen only when the determinant is 0. Determinant of all the three should be 0. So this equation gets converted to this condition. Okay. So if you solve this determinant, you will get this particular condition. As simple as that. Whenever you are talking about shortest distance between two curves, it could be in two-dimensional geometry, it could be in application of derivatives, it could be in three-dimensional geometry also. Shortest distance between two curves, remember, will always be along the common normal. Let's say I have one curve, another curve. Shortest distance between them or largest distance between them will always be along the common normal. So, shortest distance between two non-intersecting curves will always lie along the common normal. It will be along their common normal. Okay. So whenever you have to find shortest distance, find a common normal, and that will serve the purpose. For example, here you are given a straight line, y is equal to x minus 2 is a straight line, and you are given a parabola. You are given a parabola. Which parabola? Y is equal to x square plus 3x plus 2. Now you are supposed to find the shortest distance between them. The shortest distance you can see in the graph is this distance, and it will always be along the common normal. It will always be along the common normal. So find normal of the parabola. Find normal of the parabola. What is dy by dx? Okay. What is dy by dx? Y dash is 2x plus 3. Y dash is 2x plus 3. Now what is happening to our normal? It is perpendicular to the line y is equal to x minus 2. It is perpendicular to the line y is equal to x minus 2. So our normal to the parabola should also be normal to this line y is equal to x. Any line perpendicular to y is equal to x, its slope will be minus 1. So 2x plus 3 is equal to minus 1. Sorry, this is tangent slope. This tangent slope which I wrote. So tangent at this point should be parallel to the line y is equal to x minus 2. If normal is perpendicular to the line y is equal to x minus 2, tangent should be parallel to y is equal to x minus 2. So 2x plus 3 should be equal to 1. Slope of the tangent to the parabola and the given curve, the other line, should both be equal. From here you get the value of x. X is equal to how much? Minus. X is equal to minus 1. Accordingly, you can find the point on the parabola. Substitute the x value. Y coordinate, how much will it be? Minus 1, 1, plus 2, 3, 0. Minus 1, comma 0. So, what is the corresponding point on the parabola? It is minus 1, comma 0. So, what will be your shortest distance? Find the perpendicular distance from the point minus 1, comma 0 onto the line y is equal to x minus 2. That will give you the result. Okay. Find the perpendicular distance from the point minus 1, comma 0 to the line y is equal to x minus 2. That will give you the result. So, for shortest distance between any two curves, what is that you need to do? Find the common normal. Assume normal to any one curve. Apply the condition that it is also normal to the second curve. If it is circle, make it pass through the center. If it is line, slopes of tangent are equal. So these things you can do and find the corresponding points and then find the distance between them. Another question. Let P h comma k be a point on the curve. Curve is given. P h comma k is a point on this curve, which is nearest to the line. Nearest to the line. Again, same pattern question. One parabola is given and another straight line is given. So I want a point on the parabola h comma k, which is nearest to a given line. Y is equal to 3x minus 3. So at this point h comma k, what should happen? Tangent slope should be parallel to these two lines, should be parallel. Then only it will be the nearest point. So at h comma k, what will be the tangent slope? Derivative y dash is 2x, substitute 2h plus 7. This is slope of tangent to this parabola. Should be equal to slope of that line 3. From here you get the h value minus 2. Once you know h value, you can also find k value, substitute here. He is asking you normal equation. He is asking you to find normal equation. Now tangent slope is 3. So normal slope will be how much? Minus 3. Any line with slope minus 3 will be how? 3x plus y. Tangent slope is 3. So normal slope will be minus 1 by 3. Tangent slope is 3. So normal slope of tangent is 3. These two lines are parallel. So normal slope will be how much? Minus 1 by 3. Any line with slope minus 1 by 3, how will it be? Y is equal to minus x by 3 plus c. Okay. Now how to find c? Substitute the point h comma k. H is how much? Already we got it, minus 2. So k will be how much? Substitute here, 4. Minus 14 plus 2. 6 minus 14 is minus 8. So substitute the point minus 2 comma minus 8. This point we got it to be minus 2 comma minus 8. Substitute this point here and get the value of c. Is 3y plus x is equal to y is how much? Minus 8. So minus 24 minus 2 minus 26 equal to minus. Option A looks like the answer. Okay. So x plus 3y is plus 26 equal to 0 is the normal. Okay. Then let's come to the most important and interesting part of application of derivative, monotonicity. Monotonicity has wide range of applications, right from your functions chapter to finding domain to range to theory of equations to trigonometry to a lot of other chapters. Monotonicity is It can be called the heart of entire mathematics, JEE mathematics. So this is the most important topic. Let's focus on this. A function f of x is said to be monotonic if it is either strictly increasing or strictly decreasing. Any increasing function or decreasing function is said to be monotonic function. Monotonicity about a point, first point. At any point a function is said to be increasing. There is no sense of saying at a point, but usually we say it is increasing at a point if it is increasing in the neighborhood of that point. So take any close neighborhood of a point, nearest surroundings. In that region, if it is an increasing curve, that means as you move forward, if the graph is going upwards, then you say the function is monotonic at a point A. Here what is happening? It is moving up and up. So this is also a monotonically increasing function in the neighborhood of A. So a function is said to be monotonic at a point A if it is either strictly increasing in the neighborhood of A or strictly decreasing in the neighborhood of A. It can either be strictly increasing in the neighborhood of A or it can be strictly decreasing in the neighborhood of A. Here it is decreasing in the neighborhood of A, decreasing in the neighborhood of A. Okay, that is f of A minus h, the values to the left should be more than f of A values. To the right, they should be less than f of A values. If this is happening, then the function is said to be monotonic at a point A. Let us see, when a function is said to be monotonic over an interval, either it is strictly decreasing or strictly increasing in an interval. So a function is strictly increasing in an interval. If you take any 2 points x1 and x2 in an interval, if x1 greater than x2 implies f of x1 is greater than f of x2, then the function is said to be strictly increasing. See, this is application of, actually it is definition of strictly increasing function, but in practice it is application of strictly increasing function. What does this mean is, if you have an inequality, and you know f is increasing, you can happily apply an increasing function over an inequality. You can apply an increasing function over an inequality. Also, you can remove an increasing function over an inequality. For example, e power x is a strictly increasing function. How will be graph of e power x? This is how the graph of e power x will be. It's a strictly increasing function on R. If somebody says x1 is greater than x2, then you can say e power x1 is greater than e power x2. So you can happily apply increasing function over an inequality. Similarly, you can also remove an increasing function over an inequality. So whatever operation you are doing over an inequality, you have to be very clear whether it is an increasing function or a decreasing function. In a decreasing function, what will happen? Inequality will reverse. If x1 is greater than x2, then f of x1 will be less than f of x2. So whenever you are applying or removing a decreasing function on an inequality, inequality will reverse. For example, this is the graph of 1 by 2 power x. 1 by 2 power x is a decreasing function. 1 by 2 power x is a decreasing function. So if you know x1 is greater than x2, then you can say 1 by 2 power x1 will be less than, inequality will reverse because the function is decreasing function. Similarly, log to the base a, when a lies between 0 to 1, is a decreasing function. If a lies between 0 to 1, log is a decreasing function. So if somebody says x1 is greater than x2, you can say log x1 to the base a is, inequality will reverse, log x2 to the base is less than log x2 to the base a. Okay, this is what you can conclude. So this is where the application of increasing functions or decreasing functions will come over an inequality. Then you have non-increasing functions which don't have much of a theoretical significance, practical significance. Function is decreasing or remains constant or decreasing, then it is called non-increasing function. Similarly, if a function is increasing, stays constant and increasing, it is called non-decreasing function. So together all these 4 types are called monotonic functions. Let us come to the derivative part of this. Here we have to be a little careful. The statement is right but not complete. So to test monotonicity about a point A, if f dash A is greater than 0, then f of x we can say it is increasing at A. If f dash A is greater than 0, then you can say f of x is increasing at A. Then converse is need not be true. For the function to be increasing at A, f dash A need not be greater than 0. The function can be non-differentiable, still it can be increasing. A function can be discontinuous, still it can be increasing. A function's derivative may be 0, still it can be increasing. Okay, so for increasing, this is not the condition. But if f dash A is greater than 0, then you can happily say it is increasing. For function to be increasing, you cannot compel f dash A to be greater than 0. It need not be the case. But if f dash A is 0, you can happily say it is an increasing function. Similarly, if f dash A is less than 0, you can say it is a decreasing function at the point A. If f dash A is 0, then you cannot say it is neither increasing nor decreasing. It can still be increasing or decreasing. What you have to look at is f dash A plus, what is happening after the point and what is happening before the point. For example, if you look at the function x cube is a strictly increasing function. X cube is a strictly increasing function. However, derivative at x0 is 0. Derivative at 0 is 0. But still the function is increasing at 0. After 0, if you take immediate value, it will be positive. Before 0, if you take values, it will be negative. It's the increasing function at 0. But what is the derivative? 0. So here what we have to observe is, look at the values immediately after this. What will be the slope of the tangent immediately after this? It's a positive slope. That means f dash 0 plus is greater than 0. What is the slope immediately just before this? That is also positive. And f dash a minus is also positive. If both of them are positive, then you can say f of x is increasing function. F of x is increasing function. If both of them are negative, you can say if it is a decreasing function. But if it is one is positive and other is negative, for example, x power 4, derivative is 0, but this side slope is positive, this side slope is negative. Then it is neither increasing nor decreasing at that point. Okay, so if both sides derivative is positive, then it is an increasing function. If both sides derivative is negative, it is a decreasing function. If on one side it is positive and on the other side it is negative, it is neither increasing nor decreasing. So fortunate is, if f dash a you found it to be greater than 0, happily you can say it is an increasing function. If f dash a you find it to be negative, you can say it is decreasing function. If it is 0, don't ignore saying that it is neither increasing nor decreasing. Find the values to the left and to the right. If both of them are positive, increasing function. Both are negative, decreasing function. Otherwise, it is neither decreasing nor decreasing. So let us understand this by an example. Observe the nature of this function, that means the monotonicity at these points 0, 1 and 2. So find out f dash of x. What is f dash of x? 3x square minus 3. 3x square minus 3. 3x square minus 3, what can you say about it at 0? At 0, f dash 0 is minus 3. F dash of 1 is 0. F dash of 2 is 4, 3 is 12 minus. So here you can say it is a decreasing function. At 0, f dash is negative, so it is a decreasing function. At 2, it is 9, it is increasing function. But at 1, it is 0. I cannot dismiss saying whether it is increasing or decreasing. Let me observe. This is what? 3 into x square minus 1. X square minus 1 is x minus 1 into x plus 1. X minus 1 into x plus 1. Okay. So let me observe the sign of this using wavy curve method around 1. After 1, this expression will be positive, between negative, here positive. At 1 it was 0, at minus 1 also it is 0. Now, what is the nature of this curve at 1? To the right side f dash 0 is, f dash 1 plus is positive, f dash 1 plus is positive. f dash 1 minus is negative. So to the right it is increasing function, to the left it is decreasing function. So on the whole it is neither increasing nor decreasing. Is that clear? We have absolutely no doubt at 0. F dash 0 was negative, so it is decreasing. F dash 2 was positive, so it is increasing. Our only problem was with 1. F dash 1 is 0. So I observed f dash 1 plus and f dash 1 minus. F dash 1 plus directly also you can say, or you can use wavy curve method for that. If I have to use directly, x is slightly greater than 1. So this is positive. 1 plus 1 is anyways positive. 3 is also positive. This is greater than 0. F dash 1 minus, what will it be? X is slightly less than 1. When x is less than 1, x minus 1 is negative. This is positive, positive. So this is negative. Or you can also plot your wavy curve and discuss the sign. So one side it is positive, other side it is negative. So it is neither increasing nor decreasing. Now this function is monotonically decreasing at which of these points? Here problem is we have modulus. Okay, we need to be a little careful with the modulus symbol. So I'll split the discussion into two cases, x greater than 1. F of x, what would it be? X minus 1 by x square. If x less than 1, is 1 minus x by x square. If x is equal to 1, is 0. This is the definition of the function. Now let me find f dash x. Derivative of this would be, first part is 1 by x, derivative is minus 1 by x square. Then I have minus 1 by x square. Derivative of this would be 2 by x cube. X is greater than 1. If x is less than 1, is 1 by x. Simple sign change of this, 1 by x square minus 2 by x. Now at x equal to 1, what is the value for this? 1. This is minus 1. So the function is not differentiable at 1. The function is not differentiable at 1. It will have a sharp point at 1. It will be continuous, but it will have a sharp point. If you draw the graph, it will have a sharp point at 1. It will not be differentiable at 1. Okay. Now let us see about monotonicity of this function. Where is it monotonically decreasing? At x is equal to 3. X equal to 3 falls under which category here? If I substitute 2 by 27 minus 1 by 9 is negative. So at x equal to 3 it is decreasing. X equal to 3 it is decreasing. At x equal to 1. At x equal to 1 what is happening? The function is not differentiable. So let me understand the derivative to the left and to the right. To the left side of 1 it is 1. To the right side of 1 it is minus 1. So one side it is increasing, other side it is decreasing. So it is neither increasing nor decreasing at 1. At x is equal to 2. X equal to 2 falls here. 2 by 8, which is 1 by 4, minus 1 by 4. Derivative is 0. Derivative is 0. So at x equal to 2, let me do it carefully. What is the function? 2x square minus x cube divided by x power 5, which is x square into 2 minus x divided by x power 5, and this will be x cube. Now 2 minus x power is odd, 1. So above 2 this will change its sign. If x is more than 2, it will be negative. If x is less than 2, it will be positive. So again on 2, one side it is positive, other side it is negative. So this is neither increasing nor decreasing. So there is only one point where it is monotonically decreasing, that is x is equal to 3. This is how you check monotonicity at a point or a interval. And in an interval, if f dash x is strictly increasing in an interval, if f dash x is greater than 0. See, the other side it is not a condition. For a function to be strictly increasing, f dash x need not be greater than 0. A function can be discontinuous and still can be strictly increasing. A function need not have a derivative but still can be strictly increasing. Okay, but if at all f dash x is greater than 0, then happily you can say function is strictly increasing. So it is correct technically, but it is not complete. If a function is increasing, if f dash x is greater than or equal to 0, increasing means you mean to say it is non-decreasing. Non-decreasing if f dash x is greater than or equal to 0. If f dash x is less than 0, it is a strictly decreasing function. If f dash x is less than or equal to 0, it is a non-increasing function. Let us be a little more precise about these definitions. If f dash x is greater than or equal to 0, f dash x is greater than or equal to 0, and equality is not forming any interval, equality is not forming any interval. If equality forms an interval, what happens is over an interval, f dash x is a constant function. F dash x is a constant function over an interval. So in that case, it will be increasing, then constant, then increasing. So it will be a non-decreasing function. But if it is not forming an interval, equality doesn't form an interval. Equality, if it doesn't form any interval, then f of x would be strictly increasing function. So for a strictly increasing function, f dash x need not be greater than 0. F dash x can still be greater than or equal to 0. You have to be very careful with this point. But you have to ensure that equality is not forming any interval. Equality can still be at few finitely, discretely many points. Discretely many finite points. For example, already we discussed this example, x cube, a strictly increasing function, and at x equal to 0, derivative is 0. Still it is strictly increasing because it is only 0 at a point 0, it is not 0 over an interval. Similarly, if the f dash x is less than or equal to 0 over an interval and f dash equal to 0 is not forming any interval, then f of x would be a strictly increasing, strictly decreasing function. So you have to be very careful this equality sign, especially in cubic questions and all other questions. The question is find the necessary condition that the function is strictly increasing. He will give you a polynomial. Then you don't just have to put greater than 0, you have to put greater than or equal to 0. You have to be very careful there. Which of the following statements is correct? Quickly tell me, which of the following statements is correct? X plus sin x is increasing function. Why? What is the derivative? 1 plus cos x. 1 plus cos x is always greater than or equal to 0. Why? Cos x always lies between minus 1 and plus 1. Because cos x lies between minus 1 and plus 1, 1 plus cos x is always greater than or equal to 0. And equal to 0 happens only at few discretely separated points. So it is strictly increasing function, happily correct. Secant x is neither increasing nor decreasing function. Secant x is neither increasing nor decreasing function. How? Why? Obviously the graph of secant x, it will go up, is coming down and then going up, then going up, then coming down. So it is neither increasing nor decreasing function. The statement is also right. X plus sin x is decreasing. Obviously if A is right, C cannot be right. Last one, secant x is an increasing function. Obviously not. So A and B are your answers. A and B are your answers. This function 3x minus 7 into x power 2 by 3, he is asking you in which of the intervals is an increasing function. In which of these intervals is an increasing function. So find f dash of x. What will be f dash of x? Apply UV rule. Derivative of this is 3x power 2 by 3 plus 3x minus 7. So what is derivative of this? 2 by 3 x power minus 1 by 3. So I'll take x power minus 1 by 3 common. If I take x power minus 1 by 3 common, then this will become x power 2 by 3 into x power 1 by 3, x 3x plus this 3 also I can take common, square plus 2 into 3 6x minus by 3 I took common. Okay, so let me simplify this. This is x power minus 1 by 3 into how much is this? 9 plus 6, 15x minus 14 divided by 3. Okay, so x power minus 1 by 3 varies its sign according as x is positive or negative. If x is positive, x power minus 1 by 3 is positive. If x is negative, x power minus 1 by 3 is negative. 15x minus 14 will vary its sign depending on x is greater than 14 by 15 or x is less than 14 by 15. So here it will be positive, negative, positive. Where we want it to be increasing. So it will be increasing in the interval minus infinity to 0, union 14 by 5 to infinity. Minus infinity to 0, union 14 by 5 to infinity. That will be your region. Option A. So it will be increasing in this particular interval. Okay. Now to be more precise, I will have to have these intervals as closed intervals. Okay. These intervals can be closed intervals. Next. Quickly do this question. F of x is equal to 2x plus cot inverse x plus ln of root over 1 plus x square minus x. Then f of x increases or decreases in which intervals? F of x increases or decreases in which of these intervals? So find out f dash of x. Find out f dash of x. F dash of x will be 2 plus derivative of cot inverse x will be minus 1 by 1 plus x square. Minus 1 by 1 plus x square plus derivative of this will be what? There is an interesting way with which you can answer it, but I will plainly do it by differentiation first. 1 plus x square minus x log of any number is 1 by that number into derivative of this. Derivative of this quantity will be x by root over 1 plus x square minus 1. Now if you see root over 1 plus x square minus x, x minus root over 1 plus x square gets cancelled. So what will you be left with? Minus 1 by root over 1 plus x square. Minus 1 by root over 1 plus x square. And then this is minus 1 by 1 plus x square plus 2. Now what can you say about this? This looks like a complicated equation to solve. Like a complicated equations to solve. Yes or no? But if you look at it with care, this denominator is always greater than or equal to 1. Yes or no? Denominator is always greater than or equal to 1. So what can you say about 1 by 1 plus x square? This is always a quantity which is less than or equal to 1. 1 by 1 plus x square is always less than or equal to 1. Same is the case with 1 by root over 1 plus x square. That is also a quantity less than or equal to 1. Now from 2, you are removing a quantity smaller than 1. And again you are removing another quantity smaller than 1. So can this ever be negative? No, right? So this will always be positive. Look at it once again. This quantity, यहाँ पे minus sign है. यहाँ पे भी minus sign है. Okay. Now focus on this quantity. This is always less than or equal to 1. Focus on this quantity. This is always less than or equal to 1. Now from 2 you are removing something less than 1. तो आंसर कितना होगा? 1 से ज़्यादा होगा. उसमें से I am removing another quantity less than or equal to 1. What will happen to that? That will also be positive. So overall this quantity will always be positive. So f of x increases for all values of x. F of x increases for all values of x. So f of x increases in minus infinity to plus infinity. F of x increases in minus infinity to plus infinity. Option D is the right option. You can as well say among the subsets, if it is a more than one option question, then A and B would also be the right answer. Now look at this question. F dash x is given to be mod x minus fractional part of x. Mod x minus fractional part of x. Then f of x is strictly decreasing in which of these intervals? F of x is strictly decreasing in which of these intervals? So to understand this, there are multiple ways of doing this question. One method which I would prefer is drawing a graph. Is the graph of mod x. How would be the graph of fractional part of x? From 0 to 1 is same as x. Both the graphs will be one and the same. From 1 to 2, this green one is the graph of mod x. Blue one is the graph of mod x. Green one is the graph of fractional part of x. Now you want mod x minus fractional part of x to be negative, strictly decreasing. Now in this region, what is happening from 0 to 1? Mod x and fractional part of x are same. From 0 to 1, mod x and fractional part of x are same. So derivative would be 0. Derivative would be 0. So it is not strictly increasing, it is constant function. Okay. After that, mod x is more than fractional part of x. So mod x minus fractional part of x is positive in this region. It will be a strictly increasing function. I want strictly decreasing. So where is mod x? Where is the green graph? Above the blue one. Where is fractional part of x more than mod x? Where is the green one above the blue one? Only in this part. What is this one? This is where these two lines intersect. Half. So only when x is between minus half to 0, only when x is between minus half to 0, okay, it is a strictly decreasing function. Everywhere else it is a either a strictly increasing function or from 0 to 1 it is a constant function. From 0 to 1 it is a constant function. Minus infinity to minus half it is a strictly increasing function. Minus half to 0 it is strictly decreasing. Then again from 1 to infinity it is strictly increasing. Next question. Phi of x is given by f of x whole cube. These type of questions are being asked regularly. You have to practice them thoroughly. Phi of x is, look at the derivative of this, phi dash of x is how much? 3f square into f dash minus 6f into f dash plus 4f dash plus 5 plus 3 sin x, derivative is 3 cos x minus 4 sin. This is the derivative, which is f dash into 3f square minus 6f plus 4 plus 5 plus 3 cos x minus 4. Now, you have a trigonometric expression, then you have a quadratic in terms of f of x, then you have f dash of x. You have f dash of x, you have a quadratic in f, and you have a trigonometric expression. Now, what is the discriminant of this quadratic? Discriminant of this quadratic is b square 36 minus 4ac, 4 into 3 into 4, 48. Discriminant is negative. Discriminant of this quadratic is negative. When discriminant of a quadratic is negative, what do you call that quadratic as? Irreducible quadratic. This will be a irreducible quadratic. You cannot further factorize it into linear factors. Irreducible quadratics are either positive, they are always positive, or they are always negative, depending on coefficient of x square. Here f square. So f square coefficient is positive. So the expression will always be positive. This will always be positive. Whatever be the value of f of x, this will always be greater than 0. Now look at 3 cos x minus 5 sin 4 sin x. 3 cos x minus 4 sin x, you know a cos x plus b sin x will always lie between minus root over a square plus b square to plus root over a square plus b square. So this quantity will always lie between 0 to 10. Least value of this will be when 3 cos x minus 4 sin x is minus 5, 0, and the greatest value will be 10. The range of a sin x plus b cos x plus c will be c minus root over a square plus b square to c plus root over a square plus b square. So these quantities are again greater than or equal to 0. This is greater than or equal to 0. And option A, what is it says? Whenever f is increasing, that means f dash if it is positive, f dash if it is positive, this is positive, this is positive, this is positive. Sum of all of them will be positive. So 5 will be an increasing function. Option A is absolutely right. Option A is absolutely right, because what you can see there, f is increasing, so f dash is positive. This quantity will always be positive. That quantity is always non-negative, so sum will be positive. Now look at option. This cannot be said. I'm not sure about B. This is also not be said. Partially it may be positive, partially it may be negative. Part of it is positive, part of it is negative. Unless you know relatively what they are, you cannot say whether total is positive or negative. This is again an interesting option. If f dash x is minus 11, f dash x is minus 11. Now what is range of this quadratic? 3f square minus 6f plus 4 is nothing but 3 into f minus 1 whole square plus 1. Yes or no? 3 into f minus 1 whole square plus 1. Our discriminant of a quadratic is given by its least value or greatest value is given by minus d by 4a. You calculate minus d, minus of minus plus 12 by 4a, 12, it will be 1. Least value will be 1. So this quantity will always be greater than or equal to 1. Exact. For first question, we just wanted to check whether it is positive or not. For this question, I have to be a little more particular. This is greater than or equal to 1. Now f dash x he says is minus 11. So this quantity is less than or equal to minus 11. Left hand side is less than or equal to minus 11, and this quantity is less than 10. So their sum will be less than or equal to minus 1. Their sum will be less than or equal to minus 1. So it will automatically be a negative number. So option D is perfectly right. इसका नेगेटिव वैल्यू कितना है? 10 से कम होगा. ये कितना है? minus 11 है. This is always greater than or equal to 1. Some number some number greater than 1 multiplied by minus 11, that number will always be less than minus 11. A number less than minus 11 plus a number less than 10 will always give you something less than minus 1. So this will always be a negative number. Because f dash is negative, f dash is negative, phi is decreasing function. Very interesting question. Next one. Even this question is being asked regularly in advanced as well as in main. If you have a problem with phi, I will write g. G of x is a polynomial and g dash x is greater than g of x for all x greater than or equal to 1. G of 1 is equal to 0. G of 1 is equal to 0. He is asking you to talk about various values of g. Okay. Now, whenever you see this g dash and g, this resembles a linear differential equation. It resembles a linear differential equation. So I'll multiply by the integrating factor, which is e power minus x, dy by dx minus y. So p is minus 1 here. Q I will forget. Integral part will be integration factor will be e power integral minus 1, which is e power minus. So I'll multiply throughout by e power minus x, and e power minus x is a positive number. So happily you can multiply it over an inequality. We will question it. Okay. So from this you can write this. Now what you can see is derivative of e power minus x into g of x is greater than 0. Derivative of e power minus x into g of x is this quantity, is given to be greater than 0. So you can see the function h of x is equal to e power minus x into g of x is an increasing function. Up arrow means increasing function. This function is an increasing function. This function is an increasing function. Now I have to talk about what is happening for the values of x greater than or equal to 1. Because h is increasing function, if x is greater than or equal to 1, implies h of x is greater than or equal to h of 1. You can apply or remove an increasing function over an inequality. If x is greater than or equal to 1, h of x will be greater than or equal to h of 1. h of x क्या होगा? E power minus x into g of x is greater than or equal to h of 1 कितना होगा? G of 1 is given to be 0, so e power minus 1 into g of 1 is 0. So e power minus x into g of x is greater than or equal to 0. Now e power x positive है, दोनों का product positive है, तो what can you say about g of x? It should also be positive. So for the product to be greater than or equal to 0, e power minus x is always positive. So g of x should also be greater than or equal to 0 when for all x greater than or equal to 1. Okay. So g of x, which is your phi of x, should be greater than or equal to 0 for all x greater than or equal to 1. That is your condition. Very important. Almost 4 to 5 times such type of questions are asked both in JEE as JEE main as well as in JEE advanced. So be thorough with that. This is also a similar equation. This is also a similar equation. Only thing is the integration factor would be different. F dash x cos x minus f of x sin x. Look at this and identify what is this expression. It is derivative of f of x cos x. F of x cos x. Now this is given to be less than or equal to 0 for all x greater than or equal to. So this is given to be less than or equal to 0 for all x greater. What you can conclude from here? F of x cos x is an decreasing function. It is a decreasing function in the interval 0 to infinity. Interval close 0 to infinity, it is a decreasing function. Okay. Now f of x is said to be non-negative continuous function. F of x is said to be non-negative. F of x cannot be negative. Now f of x cannot be negative. F of x cos x is a decreasing function. F of x cos x is a decreasing function because f of x cos x derivative is less than or equal to 0 for all x greater than or equal to 0. Now if this is a decreasing function, then f of x cos x should always be less than or equal to how much? Because this is a decreasing function, for all x greater than or equal to 0, f of x cos x should be less than or equal to f of 0. F of 0 into cos 0 is 1. should be less than or equal to f of 0. Okay. Should be less than or equal to f of 0, whatever be the value of now f of 0 and f of x are both given to be positive. F of 0 and f of x are both given to be positive. Equal to 0 for all x belonging to R. This derivative is less than or equal to 0. So this is a decreasing function. Fair enough. ठीक है, इसका भी जरूरत नहीं है. You don't even need to look at this. Now observe, f of x cos x is a decreasing function. F of x cos x is a decreasing function for all x belonging to 0 to infinity. Now identify the pattern of cos x. It is partly negative, partly positive, partly negative, partly positive. है कि नहीं? This is how cos x will behave. Now f of x is positive. If f of x is positive, f of x into cos x will also remain positive whenever cos x is positive. F of x into cos x will remain negative whenever cos x is negative. F of x into cos x, because f of x is always positive, f of x is always greater than or equal to 0 for all x greater than or equal to 0. So this quantity is always positive. Now ये जब positive होगा तो f of x positive होगा, ये जब negative होगा तो negative होगा. So f of x into cos x will also be like this wave equation. You will follow the same wave behavior like that of cos x. Whenever cos x is positive, this will be positive. Whenever cos x is negative, it will be negative. So it cannot be a strictly increasing function or a strictly decreasing function. It is partly increasing, partly decreasing, partly increasing, partly decreasing. But what you got this derivative to be less than or equal to 0, less than or equal to 0. So this cannot be decreasing function. As the nature suggests, this cannot be decreasing function. Then whatever our assumption is that this decreasing function is wrong. Then what is the possibility? It can only be equal to 0. It can only be a constant function. F of x has to be 0. It cannot be decreasing because it's partly increasing and partly decreasing, partly increasing and partly decreasing. It cannot be an entirely decreasing function. This assumption is wrong. So what is the only other possibility? F of x should be a constant function 0. Of x should be a constant function 0. Only then this is possible. So what is your answer? F of 5 pi by 3 should also be 0. Is it clear? F of x into cos x is coming out to be a decreasing function. If it is decreasing function, either it should be entirely negative after certain values or entirely positive after certain. But what is happening to this? Partly positive, partly negative, partly positive, partly negative, because f of x is always positive. Non-negative is what is given, and cos x is partly positive and partly negative. So the same sign is continuing with f of x to cos x. That should not be a possibility with the given derivative information. So that is only possible when it is a constant function. F of x should be 0. That is how you can conclude that f of x is 0. Next, some properties, basic properties of monotonicity. Monotonicity is a very important part. So f of x, if it is increasing function, then its reciprocal is a decreasing function in the intervals where f is non-zero. If f is non-zero, that is, f is either entirely positive or entirely negative. If f is increasing, 1 by f will be decreasing. If f is increasing, 1 by f will be decreasing. Next important property, f of x, if it is increasing, if you put a minus sign, which is a decreasing function, then composition will be a decreasing function. Composition of, if two functions are both increasing or both decreasing, composition of two increasing functions or two decreasing functions will always be a increasing function. In fact, composition of even number of functions. Kyun aisa? To have even number of functions, every time I am applying a function, inequality will remain same. So how many ever times you apply increasing function, you will get the same thing. If all of them are decreasing functions, every time you apply a decreasing function, inequality will reverse. If you are implying a decreasing function even number of times, their composition will again be an increasing function. If you are applying a decreasing function odd number of times, every time you apply a decreasing function, inequality will reverse. So odd number of times reverse हो गया तो effectively reverse ही बचेगा. So it will be a decreasing function. Okay. So these are the properties of increasing and decreasing functions, which will be very handy. If one function is increasing, other will is decreasing, composition will be decreasing function. So one is increasing, other is decreasing, then their composite function is a decreasing function. Because f, let's say it is increasing, when I am applying f, inequality is as it is. When I am applying g, inequality reverses. So in all, inequality has reversed, so it is a decreasing function. F of x is monotonically increasing in the interval a to b, then the greatest value for a strictly increasing function, greatest value will be at the end point and greatest and least values will be at the end points. Okay, whether for strictly decreasing function or strictly increasing function, for all monotonic functions, greatest and least values we will get them at the end points in the interval. So f of b and f of a will be greatest and least values according as whether it is increasing or decreasing. Okay, so let us look at some numericals. What is S is f maps 0 to 0, f maps 0 to infinity to 0 to infinity, g maps 0 to infinity to 0 to infinity, be decreasing and increasing functions. So f is given to be decreasing function, g is given to be increasing function. Question also is being asked regularly. H of x is f of g of x. So h of x is composition of an increasing function and a decreasing function. One is increasing, other is decreasing. Okay, so h is also decreasing function. Composition of one increasing and one decreasing will be decreasing. If f and g are differentiable for all points in their respective domains and h of x is equal to 0, now h will be defined from where to where? H is a composition from f to g, is f of g of x. So h of x domain will be that of g, 0 to infinity. Its range will be that of f. So in short, h of x should always be greater than or equal to 0. H of x should always be greater than or equal to 0. Let us see, because this is a decreasing function, x greater than 0 implies h of x is less than h of 0. H of x is less than h of 0. Now what is this h of 0 is 0? What is h of 0? It is given to be 0. So what are you getting? H of x is less than 0. But h of x, can it ever be less than 0? No, because it is a mapping from 0 to infinity to 0 to infinity. So h of x, it cannot be less than 0, it can only be equal to 0. So this cannot be a decreasing function, it can be a non-increasing function. So h of x will always be identically 0. This can only be identically 0. It is not possible for it to be entirely increasing, strictly increasing or strictly decreasing. By composition, it is coming out to be decreasing, not strictly, but it is coming out to be decreasing. Decreasing, it is not possible because its codomain is given to be 0 to infinity. H of x values cannot be greater than 0. So what can happen is, cannot be less than 0, h of x value. So what can happen is, it can be constantly 0. So h of x should be identically 0. One more similar such question, you can do it as a practice. F of x, what is the monotonicity of this function? G dash of x is 2x minus 1. F dash of x is e power x minus 1. So f dash, when is it positive? After x equal to 0, f dash is positive. F dash is negative for x less than 0. What about g dash? Up to half, Greater than half, g dash is positive. Here g dash is negative, negative. So h of x, composition of two decreasing functions will be increasing. Here h dash will be positive. Here one is f dash is positive, g dash is negative. Composition will be decreasing function. Here both are positive, composition will be increasing. So h of x is decreasing in 0 to half, increasing in half to infinity and minus infinity to 0. So minus infinity to some mistakes with the answers. F dash x, what is it? E power x minus 1. G dash x, what is it? Two x minus. Okay. Now h dash x, what will it be? Of g of x derivative, which is f dash of g of x into g dash of f dash of g of x into g dash of x. So which is f dash of e power g of x. G of x is what? X square minus x minus 1 into g dash of x is 2x minus 1. This is your h dash of x. Now I need to see when h dash of x is positive and when it is negative. It all depends on whether this is positive or negative. So cut the number line at half. Cut the number line at half. It also depends on x square minus x, whether it is greater than 0 or less than 0. X square minus x, when will it be greater than 0 and when will it be less than 0? It is x into x minus 1. Between 0 to 1, it will be less than 1. So cut the number line at 0 and 1. Cut the number line at 0 and 1. So this whole thing will depend on 0 and 1, and that thing will depend on 2x minus 1. Now come case by case here. X is greater than 1. So x square minus x will be greater than 0. X square minus x, because it is greater than 0, e power x square minus x is greater than 1. So this is positive as well as this is positive. The whole thing will be positive. Between half and 1, no repeated things. So you will have alternate plus minus signs, baby curve method, or if you want, you can still check. Between half and 1, this is positive. X is greater than half. X is less than 1. Between half and 1. So x square minus x is negative. E power x square minus x will be less than 1. So this is a negative number. One is positive, other is negative, so negative. Similarly, positive, negative. Now, what do you want h of x to be? H of x to be increasing. You want h of x to be increasing. Where will h of x be increasing? 0 to half and from 1 to infinity. So 0 to half and from 1 to infinity, h of x is an increasing function. Next question, you can do it by plain differentiation. He is only asking you range. If at all it comes out to be a strictly increasing function or strictly decreasing function, directly you can find the range. Here you can also see 1 minus x by 1 plus x, minus x by 1 plus x. So you can simplify it, find out the monotonicity, or you can also see the formula of tan of pi by 4 minus x here, tan of pi by 4 minus x here. It will be tan pi by 4 1 minus tan x by 1 plus tan x. So this will be pi by 4 minus tan inverse x, or pi by 2 minus tan inverse x multiplied by 2 is there. So from there you can discuss the monotonicity of this function. It is a strictly increasing function. Range will come by substituting 0 and 1. Okay, 0 and 1, whether it is strictly increasing or strictly decreasing, you will get greatest and least values at the endpoints. That is the whole idea. F double dash x is less than 0, then f dash x is equal to 0 exactly once, or how many times? F double dash x is simply derivative of f dash of x. So f dash of x, he says, is strictly decreasing. F double dash x is less than 0 implies f dash x is strictly decreasing function. All strictly decreasing functions are 1, 1. All strictly decreasing functions are 1, 1. So if at all it can cut x-axis, it can cut it at most once. It can cut at most once. So f dash x can be 0 at the most once in A to B. Okay. So monotonicity is also useful in telling how many roots will be there for a function. Next question, f of x, f double dash x is given to be greater than 0. F double dash x is given to be greater than 0. He is asking you to discuss monotonicity of the function. Let's say this is g of x. G of x is equal to, this is again an important question regularly being asked in main. Then he is asking when will g of x increase, when will g of x decrease, and so on. So find out g dash of x. What will this be? F dash of x, f dash of 2 minus x, and in between there will be a minus. A combination of such functions can be asked. You can have x square inside. A lot of combinations in the same pattern can be asked. Now g dash x, you want it to be increasing. When will this be increasing? When f dash x minus f dash 2 minus x is greater than 0. For g to be increasing, derivative of g should be greater than 0. Now f, what can you say about f? F double dash is greater than 0. So f dash x is increasing function. Dash x is increasing. Now for f dash x to be greater than f dash 2 minus x, x should be greater than 2 minus x, because f dash is increasing function. I can happily remove it over an inequality. X minus 2 minus x should be greater than 0, or x should be greater than 2 minus x, or x should be greater than 1. X should be greater than 1. So if x is greater than 1, what will happen? This will be positive. This will be positive. What will happen to g of x? It will be increasing function. So g of x is an increasing function in 0 to 1. Increasing function on 0 to 1, there is only one option. Sorry. Increasing function on for x greater than 1. Increasing function for x greater than 1. And for x less than 1, what will happen? Inequality will reverse. G of x will be decreasing function. So it is decreasing in 0 to 1 and increasing in 1 to 2. Option C. Option C, because for x greater than 1 is an increasing function. Our discussion is only restricted between 0 to 2. So for x greater than 1, it is increasing function. So 1 to 2, it is increasing function. If x is less than 1, this will be a decreasing function. So in 0 to 1, it is a decreasing function. And C would be your answer. Okay. So this is how your monotonicity questions will be there. Maxima, minima, it is all about differentiating and equating to 0. So there is nothing much. You have been doing that in physics. For maxima, minima, what all you need to remember is for a continuous function, to have maximum at a point, continuous and differentiable function, to have a maximum at a point, f dash x should be equal to 0. And for it to be maxima, you can use your first derivative test. If f double dash a is greater than 0, it will be a minima. Less than 0, it will be a maxima. Or most suitable is your first derivative test. Look at f dash a minus and f dash a plus. If f dash a minus is negative, that means initially derivative is negative, slope will be this way, and finally slope will be positive. F dash a plus is greater than 0 and f dash a minus is less than 0. Then this is how the curve will be initially decreasing and finally increasing. It will be a point of minima. If f dash a minus is positive and f dash a plus is negative, initially positive, finally negative, the point of maxima. So first derivative test you can use to find maxima and minima. You have been doing a lot of such questions in your physics also and in mathematics also. This is not a critical part. Most of the questions are being asked in your monotonicity. Practice monotonicity thoroughly, tangents, normals thoroughly. That will suffice for your JEE main preparation. Okay. All the very best. I will share you some more questions in these slides and also some information about maxima and minima. You can go through the PDF. All the very best.